Good afternoon, students. I welcome you all for the class. Today we are going to discuss and actually we are going to continue the topic that is a DMA. So in the previous classes and in the last class, we have seen regarding the DMA transfer and DMA controller, everything we have seen in the last class. So once again, I'll be going to brush up the things like in the previous, that means in the last class, what we have discussed earlier, like we have discussed the modes of transfer. So what are the different modes of transfer, like interrupt driven IO, DMA, programmed IO? So all these are the three modes of transfer. So we have seen the programmed IO mode in interrupt IO driven IO mode. And now we have started the DMA. So what do you mean by a DMA in the sense like in short, we can say that without the intervention of CPU, we can directly transfer our data to the memory and to the IO devices. So that is the main motto of using this DMA. Why? Because when we are going to transfer the bulk amount of data, so if you are involving the CPU in the sense, it will be going to take much of the time. So what we are going to do is we are completely holding the CPU and we are taking the buses from the CPU. That is the address bus, data bus, and the control bus. All the three buses we are taking from the CPU, and by making use of this DMA, by making use of those system buses, we are directly transferring the data to the memory and to the peripheral devices. So that is the DMA. In short, we can say like that. So that is a direct memory access. The name itself indicates a direct memory access. So in this, we have seen the DMA controller also. So in this DMA controller, we have three different modes: burst mode, cycle stealing mode, and the transparent mode. So burst mode in the sense like when once the action has been started, it only releases after the completion of that action. That is the burst mode. When it comes to the cycle stealing mode, like it is going to do one task and it is going to release the bus. And again, it is going to take the charge of the buses and again, it is going to release the bus. So this is known as the cycle stealing mode. And when it comes to the transparent mode, unless the processor does not require the system bus, till then the DMA is going to wait. It is not going to charge. It is not going to take the control of the CPU when it is going to be busy. So that is the DMA controller. So we have the block, we have seen the DMA controller data transfer, how it is going to work. And we have seen the direct memory access block diagram in the last class. And today we'll be going to see this DMA transfer, how this DMA is going to be transferred. So how it is going to be transferred in the sense like we'll be going to transfer the data from the memory to the IO devices. So in this DMA transfer, let me show you the block diagram first. So this is the DMA transfer block diagram. So when we are going to see this DMA transfer block diagram, like here we can see, here we can see the CPU is there, RAM is there, IO devices is there, and the DMA is there. So how we are going to transfer with the help of a DMA? So that is the main task over here. So I'll be going to explain you with this diagram. Later you can study the theory part, right? So here you can find the DMA request line over here. So here we are going to have this DMA request line. So this DMA request line is used to request the DMA transfer. If we really want to transfer with the DMA, this DMA request line is going to be used. The bus request signal, here you will be going to have the bus request. BR in the sense bus request, BG in the sense bus grant, RS in the sense register select, RS in the sense register select, and DS in the sense device select. Let me write you over here. DS in the sense device select, RS in the sense register select, Here BR in the sense bus request, and BG in the sense bus grant. So DMA ACK in the sense DMA acknowledgement, and everything you have known, I guess. Fine. RD in the sense read, WR in the sense write. So this is how the abbreviations of DMA transfer is going to be, right? So here, as I have said you before, here the DMA request signal should be used to request the DMA transfer. The initially, this DMA request signal is used to initiate the DMA transfer. And when it has requested this DMA, then what this DMA is used to do is, it is going to send this bus request signal. So here the bus request signal is there, and here the bus request signal is there. So, and send this bus request signal used by the DMA controller, so to the CPU. So what this bus request will do is, it is asking permission to the CPU to release the buses. So that is the bus request. Release the buses. So when we have sent the bus request signal, it is going to the CPU, it is asking the CPU to release the buses. If CPU wants to release the buses, it is going to send the signal bus grant. So bus grant signal will be sent to the DMA. Fine. If it wants to, if we want the buses in the sense, bus request signal is going to be sent to the CPU. And CPU is going to acknowledge by making use of the bus grant signal, that is a BG, which is the bus grant signal. So here, the CPU activates this bus grant signal. Once the CPU activates this bus grant signal, so the buses are in high impedance state. High impedance state in the sense, so buses will be in high impedance state. High impedance state in the sense, now they can be used by the DMA transfer. High impedance in the sense, they can used by DMA. So till then, they are going to be used by the CPU. When it is in high impedance, they are going to be used by the DMA. So that is the high impedance state condition. So here, the address bus, here you can find the address bus, right? So this address bus is used to address the DMA controller and memory at a given location, right? And the device select, here you can find the device select. This device select and register select lines are activated by addressing the DMA controller. And here the read and write lines are used to specify whether read operation has to be done or whether write operation has to be done. So these are the things it is going to do. And here the DMA acknowledgement signal is there, right? So DMA acknowledgement signal, and the line is set to 1. So the system is ready to initiate the DMA transfer. Now the DMA transfer is going to be done. The data bus is used to transfer the data between the IO and device and the memory. And when after transferring the whole data, when the last word of data in the DMA transfer is transferred, then what the DMA controller is doing is, this DMA controller informs the termination of transfer. Informs the termination transfer, how in the sense? By means of this interrupt line. So here you can find this interrupt line. So this is the interrupt line. So when every transfer has done, so this is the interrupt line will be sent to the CPU that my initiation has been done. So my total transfer has been done. So this is how the DMA transfer is going to be done. Fine. This is the actual working of DMA transfer. So the main thing is, DMA request signal is going to be given to the DMA controller. Then DMA bus request is going to be sent to the CPU requesting the per buses. Then CPU, what the CPU will do is, CPU is going to release all the buses. So address bus, data bus, and the control bus. It is going to release all the buses. So those buses are being allocated to the DMA. Now the DMA can use it to transfer the data by making use of this buses. Here the data select and register select are used for selecting the address when the control is under the DMA transfer. This is how the DMA transfer is going to be done in the when we are going to transfer a bulk amount of data. So here you can find the theory. Fine. So initially the DMA request line, and next the bus request signal is sent to the DMA controller. Then the CPU is going to receive the bus request. CPU is going to acknowledge through bus grant signal. This is BG in the sense bus grant. Then the address of the DMA controller at a given memory location will be done. So all these are the things that are going to be done in the DMA transfer. So you can study this theory in the later part. Fine. This is the diagram. By making use of a diagram, you can study the theory part, right? And next one is CPU to IO communication. So CPU to IO communication in the sense how the CPU and how the input output are going to be communicated. So what are the sequence of steps that are going to be done when CPU IOP communication is going to be done? So here I'll be going to explain you by making use of this diagram. Fine. Here CPU and IOP. So CPU and IOP communication in the sense how the CPU and how the input output processor is going to be communicated. So how it is going to be communicated in the sense first initially the CPU sends an instruction to the IOP. So first initially the CPU sends an instruction to the IOP. So why that instruction is going to be sent in the sense, so to test that IOP is free or not. So here this IOP responds by inserting a status word to the memory for the CPU to check. So it is going to insert the status word in the memory. Here, after inserting the status word here, if the status is okay, then start IO instruction to IOP. So IO instructions are going to be set. Then accessing of memory to IOP program is going to be done. Here, the control of IO transfer using the DMA is going to be done. Prepare the status report, and once the transfer is completed, so it has to interrupt the CPU that my transfer has been done. So request the IOP status. So my transfer has been done. Here the transfer status go to the memory location, and then it is going to check the status for another communication. So this is how CPU to IOP communication is going to be done. So these are the two important topics which you will be going to get for the short answer. CPU to IOP communication in the sense how the processor and input output processor is going to communicate. So these are the actions that are going to be takes place, and these are the steps that are going to be followed when we are going to communicate with the CPU and IOP communication. Fine. Here the status word indicates the condition of IOP device. The CPU refers the status word. The CPU sends the instructions, and all the checkings are going to be done in parallel in order to communicate. So this is how the CPU to IO communication is going to be done uh, in this format. So these are the things that are going to be studied today. Fine. DMA transfer and CPUT IOP communication. Fine. And that's all for today's class, students. In the next class, we'll be going to wind up with the second unit by learning the last topic, Intel 8089 processor. And later on, we will be going to have the doubt session. Fine. Thank you all, students. Have a great day.